Alright, time for another DraftPhysics.com video presentation. Debate physics also. So physicist Michael has made another video, and I'll say again, hard to know what audience it's for. It's as if he's making an argument against somebody who disputes that gravity is 9.8 meters per 1 second. Per second. He says it has to be per second squared, so that's the distinction I guess the whole video is intended to demonstrate, that you must understand it as 9.8 meters per second squared or you're missing something vital. Now, that seems pretty directed at me. Okay, so I just don't see how anyone else could find the video at all interesting, because it's basically just pointing out that yes, this has already been demonstrated 5 million times. Nobody needs to prove gravity. Galileo did it 500 years ago. I mean, it was already done 500 years ago. And the stuff Galileo pointed out was, is already well known, and I could show other physicists describing it. And, oh, we got a little too bright. All right, sorry, the lighting's always changing here. Anyway. So this is, Julius Sumner kind of explains this, but, it's this 1, and then in the second you fall 3, and in the third second you fall 5. And it's this distance that is quadratic. It's the distance that's a quadratic equation. This is the 4, okay, which the square root of is the 2, which means 2 units of force. This 5, 3, 1 equals 9, the square root of which is 3 units of force. So you can clearly calculate how many units of force you've received. Now, if you wish, you can have the 9.8 meters per 1 second, or you could have it per 1 minute and change this number, or per hour and change the number, or per any unit, really, frankly. It could be you could just make up your own little time unit, and you could figure out the commensurate 9.8 to go with it, the right number. But clearly it's the distance that's quadratic. Here's the 4, okay, here's the 9, here's the 16. That's what's quadratically increasing, is the amount of distance you travel. And it's just about units of gravity. So again, it's 9.8, okay, per 1 second. So each second you gain 9.8 of velocity. So in 2 seconds you have the 19.6. You got 2 units. And the key factor is right here. All right, and the distance you travel kind of gives it away too. You can see the 4 in here, because this is 4.9 meters, this is 4.9 meters, this is 4.9 meters, this is 4.9 meters. You got 4 of those. But anyway, in the 2 units of time. And so there's no squared, you don't need to square any seconds here to understand that that's the relationship, and you can derive the 9.8 without ever considering squaring anything. You don't need to square anything to understand it's 9.8 per 1 second, and it reveals itself fine. And what it also reveals is that you're going 1/2, okay, your velocity here. So if this is your total velocity, it's always, okay, 3/4, yeah, 3/4, of the distance is always, okay, where you're going half as fast, whether you're going up or whether you're going down. So if you're falling in gravity, you go half your speed. If you only fell 2 seconds, you go half your speed after only traveling 1 unit of distance. And then you gain the second half of your speed here, okay, to go to velocity, to finish with 2 velocity. So this entire long distance, okay, per foot, per inch, you're only getting 9.8 over this huge area, where here you're getting the 9.8 over a very small area. Clearly not proportional in terms of the relationship between how much distance you're traveling and how much force you're actually collecting. Because you're always collecting it in units of 1 second. 1 second. 1 second per unit of force. No squared seconds, no need to square anything. So it would be just as easy for them to write any formalization by just recognizing that I can detect measuring your total distance, I can just take the square root of that and detect how many units of gravity you got. And if the units are in seconds, then I know how many seconds you traveled. So this, like I said, this number can change. I can make this a 2 seconds, and I can change this number to 19.6. I can make it a ½ second. I can make it anything I want, and then this would be my number that I would merely multiply or divide into the square root of the distance. And that'll tell me how many seconds, how much time it took. So it's 2 units of time. There's no quadratic amount of time. Okay, when you drop 4 times the distance, you only fall for 2 units of time. So it's obviously not quadratic. And you only collected 2 units of force, and you only weigh twice as much. Everything points to 2, 2, 2, 2, 2. Okay, and 4 is just an illusion of the fact that you've acquired past velocity and you're riding with that. That's adding, okay, to your distance. This distance is the 9.8 here. What you acquired here is this hunk here. This is the new hunk. So in the second this is your first second. This 9.8 you got for free because you're already going 9.8. And this little bit here, this whole little 4.9 is the only part you get in the second. In the third second, this part will get even bigger, and you're just going to get this one little 9.8. You're just going to keep adding 4.9 meters, and the rest of your distance is all what you previously acquired as velocity. So there's absolutely no need to square seconds. Okay, you can always manipulate a formula. Like you have some number times another number, and theoretically you could have some built-in idea or notion that it really doesn't matter as long as this total gets squared. Alright, it'll come out right. Okay, and that's really all this is just sort of a game being played about whether you square both numbers or you don't square any numbers. So squaring both and not squaring any could end up with the same total in the end. And so it's just the way they've chosen to do an equation. So they have an equation that works, but it's really not accurate to the facts. The fact is the time isn't quadratic. The distance is quadratic. So he could square the distance in the equation instead of squaring the time. And in this case, what he needs to do is square root the distance to know how many units of force he got. And then you just multiply the units of force, the number, 2 or 3. See, if I go this distance, right, my distance is 9. Okay, I take the square root of 9, I get 3. I multiply the 3 times 9.8. It's that simple. There's nothing complicated. You don't need this per second stuff. You don't need to say per second. You don't need to say second squared because there's no such thing geometrically as a squared hunk of time. It's just terrible reasoning. And there is the idea of a length being squared does make sense. But anyway, yeah, I guess I really don't need to make this a longer video. The key to the whole thing is recognizing that half the speed. That half the speed at that place indicates to you there's no rational reason for you to think there's 4 times the energy. Because it would have to collect more energy in the same unit of force. Somehow this unit of force has to give it a different amount of energy than the other unit of force. It can't give it a different amount. It's 9.8 meters. There's no way to change how much that is. And so there's no way that you can say, well, there's 4 units here. Well, there isn't 4 units though. All you got was 9.8. It's just a fact. Your velocity is only 9.6. There's no quadratic relationship. It's clearly just adding how many units of 9.8 per 1 second. Again, it's 1 second. It's not seconds, and it's not seconds squared. It's 9.8 meters per 1 second. That's what you get every single second. Not multiple seconds, not any number of seconds, not a squared amount of seconds. 1 second. Alright, so maybe that's all I need to do. I'll play the end of his video where he says you have to do the equation his way or else you won't get the right answer which is just nonsense.
If I'm trying to compare quantities that do not have the same units, we get nonsense results. We can't say that, oh, this many meters is equal to this many kilograms.
Right, nobody's doing that. So again, that's just a slander and a libel and all of that kind of crap, because nobody's messing up the units any. You're saying that there is such a thing as a unit called a squared second. I'm saying no, there are seconds. There are not squared seconds. So you've created a fictitious, arbitrarily nonsensical mechanism that, yes, in the right mathematical equation, it won't matter that you have this square in the wrong place. But if you do some other equation that's more coherent to the actual truth, okay, which is the simple relationship that you're just accruing velocity, and the accrued velocity is being collected in a quadratic amount. And that's the real truth, is that the distance you're going to get, okay, keeps increasing, keeps piling on, okay, but with each second, all you're adding is 4.9 meters of real distance, and all you're really adding, okay, is 9.8 meters of real velocity, and that's all you get. 4 times the distance, 2 units of force, 2 units of 9.8, all right, not 4 units of anything. All right, there are no 4 units. You only got 2 units, one in this tiny amount of distance and one in this very large amount of distance, and that's it. And those are the facts. Those are facts he won't refute. He won't explain how that analysis is untrue. He'll just say, you have to do math our way. There's no other equation that works. There's no other way you could arrange these numbers without using this squared factor, when, no, I could. Because it's just simple geometry. All right. And so if I want to derive this relationship of 9.8 to 1, and that's what the relationship is, 9.8 per 1 unit of force, 1 unit of time. That's all. So play some more of it and be done with it.
It just doesn't make sense. And again, whether we use the constant acceleration equation and compare that with our best fit equations, or we look at the data points individually and say, well, we can get a decent estimate. Again, it was a little bit higher error than I was hoping for, but we get a pretty decent estimate.
Again, nobody is disputing that 9.8 meters per 1 second is the ratio, is the amount of velocity you acquire in a unit of time. So again, you're just saying you have to do math our way, or the math is illegitimate, that somehow it won't get a right answer. I'm saying using the square root of the distance will give you the right answer. It'll tell you how many units of force you collected.
For this value of little g, by looking at 2 times that change in position in meters divided by the time in seconds squared. We're having to...
So again, the only reason why they keep emphasizing this time in seconds squared is they want to pretend the energy is squared. That this thing that only is in the gravity for 2 units of time, that only has twice the velocity and only will land with twice the weight, somehow has 4 times the energy. So the only reason why he's making this video or emphasizing this squared point is because I'm contending it's nonsense, that there is no squared function for time or energy.
Square that time in order to get these values. We're going to be looking at more cases of how do we look at the units of different kinds of quantities, how do we use that to our advantage in dimensional analysis, other independent ways of measuring the value of little g. So we're going to look at another experiment where we have a separate way of measuring little g by looking at the motions of pendulums, and also we're...
So yeah, will it be the distance they travel again, or are you going to use time squared again? All right, so again, it's the square root of the distance or the square of the time. I'm saying the square root of the distance is accurate to the actual geometry. That's what Galileo noticed. This is Galilean. This is 500 years old. Galileo discovered this relationship between these distances. All right, the distance is the reality. That's what you should be formalizing in your equations. Is the real thing that's quadratic, which is the distance.
Still going to find that the units have to be meters per second squared.
So they do not. It's absolute nonsense. There's no such thing as a square second. It's not geometrically consistent with reality in any way. It's just a mathematical trick. Okay, it's a misplaced way of establishing the relationship between the units. You have cheated the truth by identifying the thin thing as the fat thing, and you're getting away with it, but it's not the truth.
So those will be some of the topics in future videos. As always, if you have questions.
So all of this, okay, so again, he says he's not making these videos to me, but again, who would need this video or find it useful? For somebody to actually go to the trouble. He did an experiment where he actually threw things in the air and let things fall. And again, when doing those experiments, he could have simply pointed out, well, look, when I shoot this thing up, this line right here, 3/4 of the way up, is where it reaches half the velocity. And then when it's dropping, he could say, look, this line, 1/4 of the distance is where it's going half the velocity. It doesn't barely gain anything. This whole long three distances, these 3 units of distance it falls, it only gains 1 unit of velocity. It only gains the same velocity it gained in that 4.9 meters. It travels an additional, what would it be, 15 meters, and only gains, so in 15 meters it only gains 9.8. And it gains in this one little 4 meters the same 9.8. So you could point that out to make it just so obvious that clearly this isn't anything, this isn't linear. This has nothing to do with feet and how many inches you're traveling. This has everything to do with how long you're being affected by the force. And all you need to do is take the square root of the distance and it'll tell you exactly how many units of 9.8 affected you. Square root of the distance in full meters. Anyway, okay, so yeah, that's really should be enough. I almost want to play the other video just for the visual, but just because he has all this scale and it goes to all this trouble to do this, and you're saying, why are you doing all this if you're not going to just mark it right there and say, look, it's going half the speed here. 1/4 of the distance, half the speed. 3/4 of the distance, half the speed. So going up, it's 3/4 of the distance. Going down, it's 1/4 of the distance. I mean, a glaring statement telling you this has nothing to do with how many feet per second. I mean, how far you're going per second has something to do with how many feet you travel. How many feet you travel isn't telling you how much force you're getting added to. So you could be falling 500 miles an hour in gravity, and guess what? In the next second, you're just going to be going 509.8. It's the truth. You can be traveling 500 miles an hour towards the Earth. And in the next second, after one whole second, you're just going to be going 509.8. And after 2 seconds, you're just going to be going 519.6. Obviously, you're going to travel huge amounts of distance. And you're going to get that feeble, almost nothing amount of force. That's how it really works. And what they're trying to sell you is a lemon. A really old, rotten, Leibnizian, then French lemon. And you're buying it. And that's tragic. That you'll buy rotten, stinking, old, archaic, silly, nonsensical, wooey lemons. Alright, enough of the video. Thought I would have to say more, but I really don't, because that's all he made the video for. He says 9.8 meters per second 27, maybe 47 times in the video. Maybe 40 times. He's just trying to emphasize a justification for this nonsense of saying per second. This, what I call baby talk. It just can't mean anything to anybody reasonable. Well, anybody who's thought about it for a few seconds. How long do you really have to think about per second to say, isn't that terribly redundant? I mean, don't I know it could happen in multiple seconds? I mean, don't I know that? Do I really have to say the bullet left the gun at a certain per second because I know the guy might press the trigger again? I don't know. I mean, where do I have to, you know, you never would say I'm going 60 miles an hour per hour. Because obviously somebody knows, yeah, you could go for 2 hours or give you a 10-hour trip. Yeah, I get it. Per hour tells me all I need to know. I don't need the second per hour. Not necessary. Thank you. And clearly acceleration is in single units of 9.8 per single seconds. 1 second, 1 unit of force. No more. You're in the gravity for 2 seconds. You have 2 units of force. You have 2 units of energy. That's it. All right. So, enough said. Please be courteous and such, wherever possible. yeah. Don't be gratuitously obnoxious and nasty. That'd be a nice thing to say. I don't think I'm gratuitously nasty. I throw my little shots in here or there, but I'm really not, you know, kicking midgets or anything. All right, till the next time and such.